look at the basics. What is a table? Table follows a very standard format that we see in most all databases. Most of you are probably most familiar with Excel, which is the Microsoft database program, and it has a very similar layout. Basically, columns are fields, rows, which columns go up and down, rows go side to side. Rows are individual records, and then within an individual cell, um, you have information. So what types of tables do we have? We have attribute tables and standalone tables. Attribute tables store attributes of map features. They're associated with a spatial data layer. They also have some special fields for spatial information to make it all work. Then we have standalone tables. They can store any kind of tabular data. They are not associated with spatial data, and so they don't have they have an OID, not an FID. How do we manage all this? We manage this with the database management system. This is a dedicated system that manages tables of data. It provides data management for agencies, universities, companies. It's designed for multiple users. It focuses on data tables and tools for querying, reporting, and graphing data. Um, these systems have different kinds of setups, and one of the most common is a flat file database management system. Flat file simply stores data as rows of information in files. Think of it like a big spreadsheet. It's simple, it's robust, but it's not very efficient for searching and querying things. Another type is a hierarchical database management system. This stores data in multiple tables. The tables have these defined child-parent relationships. So like under customers, we have service calls and we have electrical usage. And then personal service is part of service calls, and billing history is part of service calls and electrical usage. And so this preset hierarchy of table relationships are designed so that there are specific queries that we use a lot, like what was the cost of the service call for Joe Smith? Joe Smith is a customer. You can go to his service calls, find out the one in question, and then that'll take you directly to the billing history to see what that cost was. Now, the way this is set up is if you know that there's certain queries or things like that that you're going to go through a lot, these pre-arranged tables are automatically sort of updated all the time so that when you need the information it's already there instead of searching through all of it to find it. It is very efficient for very specific queries, but the queries that you can run are kind of limited to how you structure the hierarchical setup. So it's not the best for everything, but if you have specific things and you set it up to address those specific things, it's much more efficient. We also have relational database management systems. This stores data in multiple tables. The table relationships are defined as needed. This makes it very flexible. It's ideal for open-ended applications when queries are not known beforehand, and this is generally the type that we use in GIS. So let's look at running queries on tables. What is a query? A query extracts certain records from a table based on a specific condition. Some examples are students with a GPA above 3.5, how many states population over a million, how many counties had greater population in 1990 than 2000, these sorts of things. These are all basic data questions that you apply to the database, and that's all the query does is it pulls out things based on specific conditions that you've outlined. We do this using a specific programming language called SQL, which stands for Structured Query Language. You can write queries that work in multiple database management environments. You can save them and reuse them. The problem with SQL is that a lot of these things are almost always case sensitive. So what we do, instead of just relying on learning SQL to type in our things, in Esri we have a graphic user interface, a GUI, That allows us to do queries, but instead of typing in the text, like in the bottom of this GUI where it says programs may have an interface to help users build SQL expressions, well, in Esri's ArcMap, they do. And what happens is you select the method of query, like create a new selection, select from selected features, remove from selected features, etc. It then shows you all the fields in your database, and you select the field that you're interested in, and then it immediately populates in the bottom box. And then you apply the function or condition statements like equals, or greater than, less than, etc. And then hit the get unique values, and it shows you what the options are for that next thing. In this case, we know it's numerical, and so we want greater than 5,000, so we don't really have to go through all that. But if, for example, if we wanted all the population 2000 data that was equal to, well, maybe let's better yet, instead of population, what if we looked at like county names as a field, and we wanted all the county names that was equal to Washington? Well, what if we don't capitalize it, or what if it's capitalized and whatever? What if we spell it wrong? Lots of things could go wrong. In a GUI like this, you would literally like select county equals, get unique values, scroll down the list, find Washington and all the variations of how it's spelled, capitalized or not, select all those, hit apply, and it runs. Now, it's likely you might have to throw an OR function in there because of some of the way some of this works between a different one. If you had, for example, a Washington that was capitalized and one that wasn't. Um, but these are much easier to use and easier to learn than trying to type all this stuff out by hand. You can use multiple criterias. Ands and ors are exactly as you would think. You can search for partial matches using these wildcard characters, and that'll help you find things that partially match what you're looking for. Or you can search for a partial term and it will find it within whole terms. You can use the like operator, and that allows you to identify things that in a slightly different way. And again, I'm not going to spend too much time explaining this here, because ultimately what happens is when you do some of the tutorial exercises, this is when you will develop these applied skills. And so the results of a query is a set of selected records that meet the criteria. Now, once you have things selected, this is important. Subsequent operations on the table will only use the selected records and ignore everything else. So once you select things, you have some options. You can export those records as a new table. You can calculate statistics on them. You can calculate new values for those selected ones. You can produce reports, or you could clear the selected features and start over. Joining and relating tables, we'll talk just a little bit more about that. To do a join, you have to have a common field. The common field does not necessarily have to have identical field names, but the data within the field has to be the same information. So whether you call it FIPS or FIPS number doesn't matter, as long as within the individual records they're FIPS numbers and they're the same number of digits, so that it's the same level of accuracy. And simply, once that's done, it joins the two tables together, allowing you to do all kinds of interesting stuff. But just remember, joins are temporary. The moment you don't need this, you can remove it. Temporary. They are used by database management systems, relational ones. They have to have a common field or a key. Treats the two tables as a single table. Original data is not affected. Can be removed when you don't need it anymore. Different types of joins. One-to-one is the simplest one. It maintains this one-to-one cardinality, is how we call it. And basically this is situations where for the one field in one table, there's a singular matching field in the other table, and so for that individual record, you're just adding the record from the other source. We have different kinds of cardinalities like one-to-one, one-to-many, many-to-one, and many-to-many. These are kind of helpful when understanding how some of this works. One-to-one would be like states to governors or countries to capitals. One-to-many would be like states to cities, districts to schools. Many-to-one would be cities to states, schools to districts. Many-to-many would be students to classes and stores to customers. Basically, when you do joins, you got a couple of things that have to happen. The first one is the only way you can put all the information in is if you're joining one field, one record to one record. And so if you have that one-to-one cardinality, you don't lose anything. If you have multiple records that have to be joined to a single source, then you have to summarize. But if you have one record that is joined to multiple records, then each of those multiple records, in this example here, the ones on the left and the bottom where it says Washington, they all get the Washington data. And so that would work. That's still one-to-one, at least in terms of the final sort of scenario individually, but it's actually many-to-one. One-to-many, that's a little more complicated. Here we have all these polygons for Washington, and we're trying to join it to the Washington polygon. You've got many things. That's just not going to work, and so that has to be summarized, or you can use a relate. And what is a relate? A relate doesn't physically join the two data sets. It links them. So if you did relate between these two data sets as you see on this screen, and then you select the polygon Washington from the data set on the left, it would then select all the polygons on the right under the state name Washington. And so it literally just, when you highlight the thing in one attribute or map, it does it on the other set of attributes. And that's all that the relates really do. If you don't have any matches, you can still complete things, so records and data sets may not entirely line up. Some classic examples of that are U.S. states data sets that include things like Puerto Rico and the U.S. Virgin Islands and Guam and the District of Columbia, all of which are U.S. territories, but they're not states. So you have to take that into consideration. But when you do that, you'll typically get nulls because you don't have matching data to go along with it, and that's okay. Multiple joins can be tricky. You cannot join to a joined source table. I like to think linear and simple. I join dataset A to dataset B, and then I export it and save it as a new dataset, and then I join dataset C to that. Then I save that and export it, and then if I have another dataset I want to join, I join it to that. I make it a series of one steps. So I hop along like a bunny on a trail, joining one to the next, making it a new dataset, joining one to it, making a new dataset, joining one to it, making a new dataset until I have everything that I need joined together. Relates are the same, tables remain separate. Personally, I don't find them terribly useful because the way that I do things in GIS, I tend to not use them very often, almost never. But they can be very useful. They just haven't really come across my plate in the sort of things that I typically do. And here's a nice example of what that looks like.